Hello friends, welcome to follow up. Let's have a look at problem 1123 again, lowest common ancestor of deepest leaves. In a previous video, we solved this problem using recursion, and in that solution, we didn't use the assumption that the nodes' values are unique. So in this video, we're going to share a solution based on traversal and in iterative format. And also, we want to take into consideration that the node values are unique. So here the strategy for finding the lowest common ancestor of the deepest leaves is very simple. So we are going to find all the deepest paths, and then we are going to retrieve or examine along the path. So we want to find the last same node. That node will be the lowest common ancestor. So if we look at example 1, so here, so we have two deepest leaves, that is, they are 7 and 4. And then these two are the corresponding passes. So we're going to have 2, the last same one. So 2 is the output for this example. So basically, once we realize this, and we can record the deepest path, and then the overall the main point of the solution we are going to share is the traversal. So let's do the coding directly. So first, I'm going to define a variable called max path, and another one is max depth, right? So this is an empty list, and this is the C0. And then we're going to do the iteration. So basically, we want to do traversal, and in the process, we track the level number of the nodes. So let's make using a depth first based solution. So here I'm going to have the root. So this is the end of the current path. So this is the root. And then the level I will set it to be 1, because here I set it the max path originally 0. Let's use 1 indexing. So now with that, basically let's do the traversal. And in between the traversal, we want to retrieve some information. That's the overall thought for this coding part. So first, let's get the parent and path and the depth, right? So this is stack pop. And then we're going to do some check if depth equal to the max depth. So in this case, so we're going to append the current path to the max path. So this is the one consideration. Another one is that if the depth is larger than max depth. So in this case, so we are going to reset the max length, max depth to be the current depth. And then we're going to reset this to be the list containing the current path. So this is the one. And basically this is the problem logic for getting the max passes or path. So then what we are going to do, that is the standard traversal. You can first examine the left subtree or right subtree. So in this problem, the order does not matter. But if we are doing problem like pre-order traversal, post-order traversal, the order of examining the left subtree or right subtree is important. So now let's first examine the left subtree, right? If we have left subtree, then what we're going to do is append this piece of information, the parent left, and then the path will be the original path appended by the current end node, that is parent left. And then the depth will be incremented by 1, right? Because we moved downwards 1 level. So actually, similarly, we can do the right. Let's copy this part, and then we do right. Right? We change this to be right, and we change this to be right, and we change this to be right. So if we do not consider this part, right? So and then we just look at the stack, and then we look at the examination here, it's nothing but traversal, right? So, but this one we take into consideration of the problem logic. We want to find the all the deepest path. So now let's first do a check. So if length of the max path equals 1, it means that the deepest leaves, the set of the deepest leaves has just one member, right? So in this case, we just return that node itself. So that is 0 on -1. So this is the one case, the special case. Otherwise, so we're going to get the leftmost path. So here is this one, and the rightmost path, and then we move from top to downwards, and we want to find the last same node. That node will be the lowest common ancestor for all the deepest leaves. Let's do this. So for this, let's do the first path, the last path. That will be nothing but max path, the first one, and max path, the last one, right? And then lowest common ancestor will be first the root, right? And then we're going to iterate, right? So for leaf 1 and leaf 2 in, so it's not leaf actually. Let's write node 1, node 2 in zip first and last. And then we're going to check if n1 equals n2, right? Like here we are going to have 3, right? And then we're going to continue, right? So we just set lowest common ancestor to be the n1 or n2. So once we arrive here, right, 7 and 4, they are different, so we do not do reset, right? So in this case, after a loop, so we just return LCA. So this is just one way of writing. So you can actually add some stop condition. Once you locate it, they are different. So just stop. So otherwise, so maybe let's write just break. So this actually forms another solution format to this problem. So before we make any comments, let's first do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So before we end this video, let's first make a comment. So here we are popping from the tail and append from the tail. So this we are using the stack behavior. But here if we pop 0, right? So this is nothing but queue behavior. So this will correspond to a solution based on depth first, right? So now let's test it. Right, okay, and now let's test, right? So that's also a solution, but it's better it change this name to be queue or something else, right? Let's recover this stack behavior. So with that said, basically that's about it for this video. Thank you.